Hi, my name is James Muscatello, and I will be presenting Lab 1 in Physics 2212, which involves charged tapes. When tape is stuck to a surface and then ripped off, the tape becomes charged through static electricity. These tapes can be used to model charges in a way that is easy to do so at home. The purpose of this lab is to find out how charges on everyday objects like tape interact with each other. The end goal of this experiment was to find exactly how many electrons are lost or gained when a tape is charged. To do this, we will first determine the charge of the tape, see how it interacts with various charged and uncharged objects, and float one tape on top of another to find the net charge. In the experiment, I found out that there is a deficiency of 8.42 times 10 to the 10th electrons on each charged tape. In this experiment, the first thing that I did was move two charged U-tapes close to each other. When the U-tapes interact, they would both repel each other when they get close enough to feel the force between them. This concludes that any two U-tapes have the same sign of charge as they repel each other. When the tapes get close to a neutral object, such as a hand or a desk, they are attracted to the surface. In addition to the U-tape, a pen can also be charged. This can be done by rubbing it against hair or a similar surface. If a U-tape is positively charged, then it should be attracted to any negative charge, so a negatively charged pen should be attracted to it. In a similar way, it can also be reasoned that a negatively charged U-tape would be repelled from a charged pen because charges with the same sign generally repel each other. If the U-tape is neutrally charged, then it should be attracted to the pen as a temporary dipole is created. In my experiment, I found that the tape was attracted to the pen, which means that the tape is positively charged as it is attracted to the negative charge on the pen. When floating one U-tape on top of another, it is necessary to know a few things to calculate the net charge. First, it is known that the momentum of the tape on top, otherwise known as tape B, is not changing. Because the change in momentum equals the net force and the change in momentum is zero, the net force in the y direction is zero. In addition, we also know all the forces in the y direction on tape B. Pointing up is the electric force of the protons on tape B from the bottom tape, otherwise known as tape A, and pointing down is the force of gravity. As you can see, the force diagram looks fairly simple, and since the net force is a known number, 0 in this case, we can solve for the unknown variables. To find the electric force between the tapes, we first have to make a few assumptions. First, we have to assume that the charge on both tapes are the same. In this case, it is reasonable because the two tapes are made in the same manner with the same length of tape, so everything is controlled in this experiment. Secondly, we have to treat the tape as if the charge were placed as a single point on the tape, which will make the calculations manageable. First, the gravitational force of the tape has to be known. To calculate this, first find the mass of the tape, then multiply by the gravitational constant g. In this case, tape B will have a gravitational force of 0.00216 newtons. Using the equations F equals QE and E equals 1 over 4 pi epsilon naught times Q over R squared, I calculated the total charge Q on the tape. This turned out to be 1.35 times 10 to the negative 8th coulombs. Then, by dividing by the charge of a proton in coulombs, the number of excess protons on the tape is determined. From this calculation, it is known that there is an excess of 8.41 times 10 to the 10th protons. This also means that there is a deficiency of the same number of electrons. To find the amount of atoms that gave up electrons, the number of atoms on the surface first must be determined. Then, with that number, the ratio of number of electrons lost to the number of atoms can be determined. To sum up these calculations, here are the main results from this experiment. Through the calculations on the previous slide, it can be established that the tape has a net charge of 1.35 times 10 to the negative 8th coulombs. In addition, there is a deficiency of 8.41 times 10 to the 10th electrons. Finally, it was determined that there is 1 electron loss per 4.97 times 10 to the 6 atoms in the tape. I know this may be hard to picture in your head, so let's take a chance to model this through GlowScript. In this representation, tape B, the point that is being floated, is on top. The two arrows pointing from it represent the two forces in the y direction, the force of gravity pointing down and the electric force from tape A pointing up. If the charge on protons and electrons switched, the experiment would have been completely the same. This is because like charges repel and opposite charges attract, no matter what the sign of the charges are. In addition, during the lab, it is important to remember not to handle the charged tapes too much. This is because the tapes will lose their charge when they are handled. The charge will spread throughout whatever touches it, so the tape will be less charged. In conclusion, this lab showed how charges interact with other charges of both like and opposite signs, as well as demonstrated how charge flows through various objects such as a hand. In addition, both the amount of charge in a tape and the amount of electrons in deficiency were calculated.